Hello and welcome to our video on Newton's second law of motion. Newton's second law of motion deals with unbalanced forces and net forces and things of that nature. So let's dive into it. Newton's second law of motion is also known as the law of acceleration. Newton would have said it somehow like this. When a net force acts on an object, the object accelerates such that the product of the mass and the acceleration equal the net force. Or we could say that the mass and the acceleration equal net force, and you can put that into a simple equation such as force equals mass times acceleration. And the forces will cause acceleration. So the force is opposite of inertia. The force changes an object's motion when inertia is what makes the object stay where it is or not want to change its motion. So the forces will change the object's motion. And the acceleration is always in the same direction as the force applied to it. So if I apply a force to an object and the force is going to the right, then that means that the acceleration will also go to the right. Now, if you want to cause greater acceleration to a mass, you have to apply a greater force. So if you want something to accelerate more, you got to push it harder. And if the same force is applied to two objects, the object with the less mass will have a greater acceleration. So if I am a golfer and I have my golf club right here and I'm going to hit a golf ball, I will be able to hit the golf ball pretty far because the golf ball has a very small mass. But let's say, for instance, instead of me trying to hit a golf ball, I put a brick in front of my golf club and I hit the brick with my golf club. That brick will not go very far because the brick has such a greater mass than the golf ball. Now, acceleration and mass are inversely proportional. But remember, our equation is F equals ma. Inversely proportional, that means that if one goes up, the other has to go down. So if I have an object and I increase the mass of the object, that means that the acceleration will go down if I apply the same force. Now that also can go the other way as well. So if I have an object and I bring down the mass of the object, it will be able to accelerate even faster. This is true for race cars. A lot of times race cars, they try to make them very light because they want the race cars to accelerate faster. So the lighter the object, the faster the acceleration. Now, force and acceleration are directly proportional. This means that if one goes up, the other goes up as well. So continuing with our same equation, F equals ma. That means that if force goes up, acceleration goes up as well. It goes the other way also. If force goes down, acceleration will go down as well. Now we need to talk about Newton's second law of motion and how it applies to weight of an object. So, weight equals the force of gravity acting on the mass. Your mass is the same on Earth as it is on the moon, as it is on Jupiter, as it is on Mars. Your mass is the same everywhere. But your weight will change on different planets because each planet has a different amount of gravity. So if I were to put it into an equation, it would say that weight equals mass times gravity of that planet or that area. And here on Earth, the acceleration due to gravity is negative 9.8 meters per second squared. So if you were to stand on a scale, the scale is calculating your mass and also the acceleration due to gravity, which gives you your weight. And gravity is different in different places of the universe. Doesn't matter, where you are. Your mass is the same, but your weight will be different. And your mass is the same everywhere. And the weight depends on the object's location in the universe.